Is it possible to move electrons in an atom and make them free electrons using only a magnetic field? In conclusion, it is not possible to make an electron inside an atom into a free electron solely through a magnetic field. Electrons within an atom are bound by the electric force of the atomic nucleus. While a magnetic field can influence the motion of electrons, it cannot exert a force on the electron equal to that of the electric force from the atomic nucleus. Therefore, it is not possible to use a magnetic field alone to completely detach an electron from the atomic nucleus and turn it into a free electron. However, it is possible to use a magnetic field to move an electron within the atom away from the influence of the atomic nucleus. For example, applying a strong magnetic field can cause the electron to bend in response to the electric force of the nucleus. In such a case, the electron can move out of the immediate influence of the atomic nucleus, but it still remains within the influence of the magnetic field. Therefore, it would not be accurate to call it a free electron in this context. Here are some methods that use a magnetic field to move electrons within an atom. Magnetic field accelerators. These use strong magnetic fields to accelerate electrons along circular orbits. As electrons move in these orbits, they gain energy, which can help them move away from the influence of the atomic nucleus. Electron spin resonance. This method exploits the interaction between the electron's spin and a magnetic field. By aligning the electron's spin in a specific direction using a magnetic field, energy can be absorbed or emitted, and this energy can be used to move the electron away from the atomic nucleus's influence. Laser techniques. Using lasers, it is possible to provide electrons with enough energy to overcome the binding energy of the atomic nucleus and move away from it. These methods allow for the movement of electrons within an atom, but they do not turn the electrons into completely free electrons. So, when a strong magnetic field is applied to a conductor, don't electrons move inside the conductor? No, when a strong magnetic field is applied to a conductor, electrons do move within the conductor. A conductor is a material composed of atoms or molecules that allow electrons to move freely. When a strong magnetic field is applied, electrons experience a force due to the magnetic field, causing them to move. The phenomenon of electrons moving within a conductor when a strong magnetic field is applied is known as induced current. Induced current is the current generated within the conductor as a result of changes in the magnetic field. When a strong magnetic field is applied to a conductor, induced current is produced within the conductor. This induced current flows in a direction that opposes the change in the magnetic field. Consequently, as the conductor moves within the magnetic field, the induced current hinders the conductor's motion. This principle is used in the operation of electric generators. Electric generators utilize the rotation of coils within a magnetic field to generate induced current and produce electricity. Therefore, when a strong magnetic field is applied to a conductor, electrons do move within the conductor, but they do not become completely free electrons. Electrons remain within the conductor and are still under the influence of the magnetic field.